Welcome to qnawire.
Okay, so we're doing chapter 18, problem 51. So it says a cubic box with side lengths 1.8 meters on each side is evacuated so that the pressure of air inside is 10 to the minus 6 torr. Estimate how many collisions molecules make with each other for each collision with a wall. And it says assume it's at 0 degrees Celsius. Okay, so from this we need to first use the ideal gas law to estimate the mean free path. So we know that N over V is P over KBT. We also know that Ln is given as 1 over 4 pi root 2 r squared N over V. So let's rearrange this. This is now KBT over 4 pi r squared root 2 P. So we can just calculate what the mean free path is from this because we know everything. So 1.38 times 10 to the negative 23 joules per Kelvin times 273 Kelvin all over 4 pi root 2. And then for the molecule radius, we're going to use 1.5 angstroms squared. And now times 133 pascals per torr to convert to this 10 to the negative 6 torr to pascals. Cool. So that's everything. We just got to plug that in our calculator. We should have joules, Kelvin, meters, pascals, everything's in the correct units. So this comes out to being 70.8 meters. Okay. So the number of collisions per second is the reciprocal of the average time between collisions. And we should know that the V bar here is given as Lm over T molecule collisions. And this is also the same as L box over T box collisions. So we can also relate this if we know that the times and lengths are related this way. We can relate the number of collisions now to N wall collisions over N box. Oh, sorry. N wall collisions over N molecule collisions. And this should equal T molecule over T wall. And we already said that the average velocity for both is the same because they're all air molecules. So this is just the ratio in lengths. So this is the mean free path of air over the length of the box. So we can just easily solve that as 70.8 meters over 1.8 meters. And we see this is 39.3. So that means there is 39.3 more times collisions with the wall than there are with the molecules. So the particles make about 1/40th of a collision with each other for each wall collision. Awesome.